There's a couple of things that you have to know before I can really do anything from Chapter 2. You have to have watched the video, but, I mean, obviously you have to do that. But you have to know how to come up with the equation of a line if someone gives you 2 points. So I'll do a quick review of that, and then I'm going to jump into the problems. So any questions, or am I okay to go? Keep going? Questions? No? You get? Okay. 2.1. Oh, you know what? I think I already started this. Yeah. Derivative as a rate of change. Let's just see, show of hands. How many of you actually did get to see the video for 2.1? Oh, yes, that's good. Okay. So the derivative as a rate of change, someone try and, I don't know, I just want to see if anyone can kind of like summarize what this section is about, just like in words. What are we trying to do? Find tangent lines. Exactly. Good. So we're trying to take a curve like this, and we're trying to find a formula that gives you, first of all, the slope of that tangent line. And then from that, if you know the slope of a line and you know a point on the line, then you can come up with the equation of tangent line. So there's two things. There's the slope of the tangent line, and then there's the equation of the tangent line. And we need to be able to find both. Okay? And to do that, what do you have to be able to compute? The definition of the tangent line right there requires that you can do what? A secant, but what's in front of the secant that's so important that we've been doing in Chapter 1? A limit. Okay? In order to define the tangent line, you must be able to do a limit, which is why we spent all that time on limits, is so that we could get to this point, which is trying to find that slope of that line. And this comes back to last class where I threw the pen across the room. And I said, what's the speed, right? At that instant in time. That's equivalent to finding the slope of that tangent line. And we actually have a way of doing it now. So the formula that you're going to need, there's two formulas that you're going to need today. The first one is the slope of the tangent line can be written as limit x approaches a, f of x minus f of a over x minus a. That's one version. If you watch the video, there's two versions of this, right? The other version is this one. And did I say in the video at all which one's better? That's right. It's going to depend on the problem you're trying to solve. There is no better or worse. It's just sometimes that first formula is nicer than the other one. Sometimes the second one's better. So, but they both give you the same answer, okay? That's the most important thing. They both give you the exact same thing. They give you the slope of the tangent line at x, or at a point. Sorry, I should say a point on the graph. So I think I think we can at least try and start with an example. I think just from the show of hands, we might be able to just jump right in. So let's look at something like number 2. It's page 80, number 2. It says, find the slope of the tangent line to the curve y equals x minus x cubed at the point 1, 0. And it says to do it using both methods, basically, both equations. And all we want is the slope of the tangent line. So find m tan. I think the first thing I'll do is I'll rewrite this. Instead of y equals, I'll put f of x equals. And where is it that we want the tangent line? Let's use the first definition, okay? And maybe we should label these the 1 and 2 here. Let's use that first one. In the first one, we actually need to figure out what A is in the first formula. What's A? Where is the x approaching? So where's that information going to come from? You have to look at the x value here. That's your x. So I'm trying to figure out what's happening as x gets close to 1. So let's write out the formula for it then. Using this equation up here. The slope, I don't think I can get this. I'm going to have to zoom out a little bit. The slope of the tangent line will be equal to the limit as x approaches what? 1 of f of x minus f of 1 over x minus 1. That's what I'm trying to compute. Does that make sense to everyone? Anyone have a question on where any of that came from? Okay, that equals limit x approaches 1. What is f of x? In this problem, what's f of x? X minus x cubed. Okay, what is f of 1? So that's f of x right there. Then minus, what's f of 1? Plug 1 into the function. What do you get? 0. Good. Then over what? X minus 1? Yeah? So I haven't taken a limit or anything. All I did was just plug the pieces in. So this limit becomes limit x approaches 1 of x minus x cubed over x minus 1. All we've done at this point is we've taken the given function and we've said, hey, look, the slope of the tangent line at that point is equal to this limit. Now we have to figure out what the limit is. So now we're back in chapter 1. So try and plug 1 in. What do you get? 0 over 0. Which you should. So 0 over 0 is some algebra or some trick. Anybody see what we can do? Factor out what? An x on top, which leaves me with what? 1 minus x squared? Is that right? Now what? Because you can't cancel anything yet. What is it? By 1 over x. Okay. I'm glad you mentioned that. Multiplying by 1 over x would get rid of your highest power of x, right? But that's what we did when you had infinity over infinity. Okay, we want to make sure we're pulling out the right tool for the job, right? The job is 0 over 0. We need algebra or a trick. There's something, it's right here. Trying to get that x minus 1 on the bottom to go away because that's what's causing division by 0. There you go. The 1 minus x squared is a difference of squares. This right here, 1 minus x squared, that's a difference of squares, and it factors. So you have x, and it turns into 1 plus x, 1 minus x, all over x minus 1. Does anything cancel? Be careful. Those aren't the same, are they? They're off, aren't they? They're off by 1. But that's okay. Anytime something's off by 1, we can always just factor a negative 1 out. So I think what I'll do is I'll leave the numerator alone. And in the denominator, I'm going to pull a negative 1 out and make this a negative x plus 1. I haven't changed the problem. By taking a negative 1 out of the bottom here, I haven't changed it. But what I have done is I've made it so that these two are exactly the same now. I have a 1 minus x is the same as a negative x plus 1.